Hello and welcome to my presentation to auth or not to auth, a comparative analysis of the pre- and post-login security landscape. This was joint work with my colleagues Metodi Mitkov, Thomas Helbrecht, Lorenz Hetterich, and Ben Stock. As you probably know, in web security research, we often crawl websites. These websites often come from top lists such as Twenco. We perform this crawl to estimate how prevalent certain security issues are on the web and to just get a feel at how many websites might be vulnerable. All these crawlers, developed by different authors and using different technologies, have one thing in common. They visit websites by using a fresh browser session for each website. How do crawlers see the web? When they visit a website, they might see something like this. In the best case, they might land on a landing page with some text and some links they can click on and continue crawling. In other cases, they just see a bot blog page because the website detected that this is not a real user, but it's a bot, or our research crawlers, which might look similar. In another case, they might just find a page with a sign-up form because the website is only available for logged-in users. The same websites might look completely different to real users. These users are probably logged in on the websites. And on the first case, they see a social media feed. In the second case, it's a location application where they see places they traveled to in the past. And in the third case, after the sign up, you find yourself on a user portal where you can manage your uploaded files. With these differences in mind, which we all know anecdotally, we asked ourselves the question, do unauthenticated crawls actually accurately reflect reality? And if not, are all the prior crawls we have done just completely misrepresenting the prevalence of security issues on the web? And if there are significant difference between the logged in and the logged out versions of websites, how do they differ? How does security differ between guests and users of our websites? There's two things that could occur here. The first is logged-in users might see better security because the website developers care more about their actual users that have an account, maybe even like pay for their account. So they improve the security on that side and they don't really care about their landing page or their logged-in view of a website. Or other thing could occur, and that is like a lot of these functionalities, as we see here in our examples, is only available after logged in, so for users that are actually logged in. And so there's just more functionality, which could result in a larger attack surface and thus also more security issue. To answer these two questions, we stepped out to perform a comparative security measurement. Here, we didn't want to reinvent the wheel, but instead wanted to repeat measurements from prior work. For this study, we focused on 4 topics. The first is client-side cross-site scripting. Here we used Foxhound, which is a taint tracking-enabled fork of Firefox, and the exploit generator from Steffens et al. From NDSS 2019. The question we want to look at is how many flows from user-controllable sources to cross-site scripting things exist, and how many of them are actually exploitable, and are there differences between the logged-in and the non-logged-in crawlers. We also want to look at security headers such as XOM options or CSP. Are there any differences in the usage, security, or consistency in the usage for these headers between the two states? Also, we want to investigate JavaScript inclusions. Do logged-in users see more JavaScript or less JavaScript? And do they see the same kind of JavaScript? So it's like inline script or included scripts, also like first-party script and third-party scripts. Lastly, we also investigated post messages. For that, we used the PM Force tool from Steffens and Stock from CCS 2020 and asked the question, how many vulnerable post message handlers exist on websites? First, I want to give you an overview of our complete workflow. In the first step, we created a crawler, which we call form detector, that, given a site to crawl, tries to find and detect the login page and the registration page if these are available. If it is successful, it will report back the login and the registration URLs. Otherwise, it will say no registration option could be found. This is helpful because in the second step, the registration step, we want to register on websites. And because we have the form detector, we only do this on websites where we know there should be a registration option, and also we directly start with the registration page. Our tool opens the registration page, and then we use the Bitwarden browser extension to automatically pre-fill the fields such as the email address or the password with the correct data. However, this process is not fully automated, so our research team has to overview it and then have to fill in additional data if Bitwarden didn't manage to fill the form correctly. Press the submit button, they might have to fill out a CAPTCHA, and then also observe our email address because as you probably know, on most websites, when you register an account, the account is not yet active, but you need to click on a link in an email, and only after that, the account is working. In the end, our research team decides whether we successfully created an account on this website or not, and reports back to the account framework. In the next step, we created a tool to perform automated login. This tool gets us input, the login URL, and the credentials of our account. It then automatically fills out the form and submits it, and most importantly, employs its own login oracle to find out whether the login was successful or not. This might be unsuccessful due to many reasons. So the account might get blocked because it got detected as a non-human user. Or also there might be a CAPTCHA after clicking on the submit button or some other error that occurred. And we only want to report that we are logged in when we actually logged in. In the end, when the login oracle says, yes, we are logged in, we store this back in our account framework and together with all the session data, such as the cookies and local storage. In the last step, experiments can then request sessions. And if there's a session available, just that was freshly verified by the login oracle, then we give it back to the experiment. The experiment then starts 2 calls in parallel. One, which is the same as all the prior calls. So we open a fresh browser session just for this website. There's nothing special about it. We just call this website. And in the other case, we open a new browser session, but then we inject all the local storage and session we had from the login step to emulate a logged in user. Let us have a more in-depth look at our experimental settings now. So with our manually assisted registration, we created accounts on over 200 popular sites. So they are from the Crooks top 5K. Then on each website, we crawl up to 1,000 same site subpages for up to 24 hours. Our crawlers use Playwright in version 1.3.3, and the browsers we use is Foxhound, which is based on Firefox 109 for the cross-site scripting experiment, because we needed to have access to the taint flows. And for all other experiments, we used Chromium in version 113. The first result we can see is that the number of collected URLs differ between the states. In the non-authenticated state, we saw an average of 840 URLs, whereas for the authenticated state, we only saw an average of 820 URLs. At first, this might seem odd. Why do logged in users see less URLs? But we had a look in our data and found a reason for that. And this is, on some side, authenticated users get redirected to a user portal where they can interact with the application, but this user portal mostly consists of buttons and doesn't have many links where they can visit other subpages of the same site. But more importantly, what is about these 4 security topics we wanted to have a look at? For the first one, we can say most flows are harmless. So in general, we couldn't detect many cross-site scripting exploits. While we had like a massive amount of sync invocation, a total of over 38 millions, we only condensed this down to around 3,000 working exploits. And these exploits were only possible on 7 sites in total, 6 which we could detect in authenticated states, and 4 we could detect in a non-authenticated state. Interestingly, there was 1 site which we found vulnerable in a non-authenticated state, but not in the authenticated state. So there was a follow-up question we came up with, and that is, are these differences due to the fact that the exploit is actually not working, so it's not exploitable in the other state, or was the vulnerable URL just not found by our crawler? For that, we run all the exploits we found in one state in the corresponding other state. Here I have a chart showing the exploits found in the non-authenticated state, run in the authenticated state. And 91% of them were exploitable, and showing that exploits you find in the non-authenticated state usually are also exploitable for authenticated users. For the other way around, it's more interesting, however. From the exploits you found in the authenticated state, only 66% of exploits were exploitable from the non-authenticated users, so from the fresh crawler, which is not logged in. And so here we see over 30% of exploits seem to be not working if you're not actually logged in. So to find more exploits, you should probably log in on websites. Our next topic was security headers. And here we saw that there's no significant difference in the usage between these headers between the two states. Sure, there are a couple of sites that only use the header in one or the other state, but in general, the usage numbers is really similar. On this table, we just show the number of sites that use the header at least once, but we also have just the total number of headers we collected, and they are also similar. Additionally, it's not only the usage, but it's also about the security of these headers. As for CSP, it's very easy to deploy a CSP that doesn't provide any real security to the websites. But also for that factors, it's very similar between the two states. As we know from prior work and also from our work where we tested every URL several times and also tested like many different URLs of the same websites, we can say that the differences between different sub-pages on a website or also just reloading the same website, same URL several times and then maybe hitting different load balancers is much higher. So there you see many differences, and these differences seem much higher than the difference due to being authenticated or not. Our hypothesis is that such security headers nowadays are mostly set at the reverse proxy level and not by the application itself. And the reverse proxy level, at the reverse proxy level, they might not even know whether you're logged in or not, or just don't care about it and always set these headers. So if you study something like this, you probably don't need to look at the authenticated state. For JavaScript inclusions, the picture is a bit different. So we looked at the number of unique scripts we saw in both states, and here they were like more than in the authenticated state, but the difference is not that high. Looking into the different types of scripts in more detail, however, we saw something striking, and that is there were many more third-party scripts when you're authenticated. And not only the number of scripts is much higher, also the number of unique third parties that we are seen in the states is higher. Interestingly, however, we also saw that quite some third parties were only seen in the non-authenticated state. So after you authenticated, the website seems to not using them anymore or not exposing you to them anymore. So depending on your research question, it might not be enough to look at the authenticated state, but you might have to look at both states and then look at the union of used third parties. The same is true for trackers, where we use the disconnect me list to find out whether a third party is a known tracking entity. And here we also see many more trackers in the authenticated state. We have to note here that our calls were performed from the European Union, where GDPR is in effect. And for the non-authenticated states, we didn't accept any cookies. Whereas for the authenticated states where we logged in, we usually also accepted the cookies, so opted in, and that might have opted us into tracking. So these results might not transfer to other countries where there's no similar regulation. Lastly, let's have a look at post-message handlers. In this figure, we see the number of post-message handlers detected in both states across how often we saw these handlers, so the frequency of them. And we see two things. First, most handlers only occur a single time and are always a little bit different. So they The unique ones are just occurring a single time. However, we also saw that some handlers occurred a lot of times on different websites or on different sub-pages of the same websites. These were mostly due to third parties such as Google Analytics. The second thing we can see here is the authenticated states sees many more post-message handlers. So regardless of the handler frequency, the blue state, which is the authenticated crawler, always detected many more handlers. With that, let me summarize our main insights. First, we can say that the impact of login highly depends on the research questions. For some, we haven't discovered a substantial difference. For example, for security headers, the login state doesn't really seem to play a huge role. However, for others, such as JavaScript and post messages, we saw much more for the authenticated state. So here it seems to matter. More importantly, however, we have to say that the authenticated state is not strictly better or worse than the non-authenticated state. We saw that, sure, some code is only reachable by the authenticated state, but also some third parties in some code is only reachable by the non-authenticated state. And as soon as you have your crawler log in on a website, they might not find some third parties anymore. While in general, the attack surface seems to be larger for the authenticated users, depending on your research question, you might want to look at the union and so study both states. Lastly, I want to mention some limitations and some ethical consideration. First, this was a small-scale study, so we only studied about 200 sites. This was mostly due to the fact that some manual labor was involved in the registration of accounts. However, even if you put more manual labor into it or create a tool that can automatically register on websites, there's still an issue. On many websites where we tried to register, we couldn't register an account. And this was due to factors such as that they require payment or phone number of a specific country, which we couldn't provide. And this issue is hard to go around. Also, on some websites, we triggered a bot detection, even though our crawlers tried to avoid it by setting certain settings. For the ethical considerations, we only tested our own accounts and we only tested client-side security issues to make sure that we are not affecting any real users of these websites. Also, we think we only caused a reasonable load on these websites because we only used 2 crawlers in parallel per site, and these crawlers also waited a short amount of time before loading the next URL of the same site to not cause too much load. Also, for all the security issues we found, such as detected cross-site scriptings, we performed responsible disclosure by notifying them via the correct channels. With that, I want to summarize our findings. First, as we already know from prior works, web measurements depend on many factors. For example, from where do you perform the crawl? Like which geolocation? Is the crawl from the EU or the US or some other country? This can have major impact. Also, it can depend on the IP. Is it like a residential IP or a cloud IP? Because cloud IPs get blocked more often as a bot. In this study, instead, we focused on the overlooked factor of login and saw this also can have a significant impact. In 3 out of 4 experiments, we saw major differences here. However, we do not know how well this transfers to other experiments and other topics. Thus, we have suggestions for future research. One should first perform a small-scale comparative crawl to estimate how much impact login has on the research question studied, and then perform a large-scale non-authenticated crawl to cover more of the web, because performing these logged-in crawls is a lot of effort and non-authenticated crawls are much easier. We also open-sourced our tool to help you in performing such comparative crawls. With that, thanks for your attention and please feel free to reach out to me.